everyone. Thanks for the opportunity today. My name is Alexandra Zhuravlyova, and I'm super excited to have a talk at the conference. In the next few minutes, I would like to share with you some ideas about human-machine interfaces and possible solutions to achieve better communication between computers and people. Future of AI might be scary. Future of AI might be paradoxical. Future of AI might be inspiring. But anyhow, future of AI is a thing to discuss. This is a highly controversial, comprehending, and intriguing topic. Talking about AI, we imagine different scenarios, starting from the almighty AGI and finishing with self-driving cars. Moreover, most of us are interacting with AI on a daily basis, checking out new music recommendations or talking to Alexa or Siri. All those AI-infused products are designed with a global idea which is spinning around one main purpose: to help us, humans, to accomplish routine tasks effectively, disregarding deeper involvement into the process. But in order to establish a connection between human and machine, we need at least to build a highly performative conversational system with the core consisting of different analytics engines derived from natural language parsing solutions. So how does perfect human-machine interface look like and what functions should it perform? In other words, how do we transfer one request to a machine? In which way? Which channel would we need to use? Text, speech, or maybe even thoughts? Remember Neuralink experiments? Or maybe a combination of both. For now, significant results are being using combination of textual and speech input, while neural interfaces are still being developed in the lab and are not really available publicly. But what happens if we would like to use only input type, like text only one? Let's start from a great textual solution, GPT-3 from OpenAI. This language model shows incredible results and boosted further kinds of transformer models to be developed, such as GPT Neo, GPT-J, etc. For those who is not so familiar with the technology, GPT-3 is a transformer language model that uses deep learning to produce human-like text and easily passes Turing tests. Nevertheless, sometimes the output of the model is daunting. For example, in October 2020, there was a case when a GPT-3-based chatbot suggested a mock patient to kill himself, replying to a simple query of, "I feel very bad. Should I kill myself? I think you should." Scary? I bet it is. So, of course, language model didn't want that person to die. It was simply guided by the context. But when it comes to live, non-utilitarian communication, the context is not everything. Empathy is also needed. At least it's high-quality simulation. Also, extremely important thing to analyze is a typographical tone of voice. With the era of information, when there is mostly informal textual communication, is being held, an extreme lack of delivered data of this kind of conversation is exists, a lot of efforts have been put to humanize chatbots in a way to sound more empathic. But what human can understand in a second, machines still not always can catch, but we are on the way. Nonverbal communication is not only gestures or facial expressions, it also includes tone of voice, which is used to reinforce our message to add another layer of meaning to it. Sarcasm is a great example. Interesting that specifically from non-verbal messages we're getting most, up to 90% in some cases, information. And here comes the speech part of the conversational AI. If the example query from the chatbot mentioned before would be passed from a real voice and validated through speech emotions, the output could be different. An additional data layer showcasing the joy, sadness, or even grief passed to the analytics engine makes it possible to get more insights from the interactive session. As a result, these insights can boost effective business optimization and increase compelling income growth. Speech emotion recognition is a hot topic to discuss. While trying to enhance the experience of problem solving via customer support, it is proven that despite some people can definitely benefit from a dialogue menu and solve their problems in a guided if else way, most of customers have an urgent need to talk to a real person, and even text to speech bots not always can help here. People want someone to hear them out, hoping for understanding. And there is a way to understand dialing customer better through speech emotion recognition system. The audio signal by its nature is not that easy to analyze, and when it comes to the speech analytics, the difficulty is growing up exponentially. Yet it's not that hard to get fine results with almost any modern CR portal at pure sterile testing conditions with clear and validated data. But when it comes from lab to field, the task starts to be more advanced. Such factors as high granularity of the incoming data, additional noise, often random peaks, speech inference are lowering the chance of finding valuable insights, and it's becoming very challenging to achieve. Specifically when you're looking up for emotions in speech in real time, but happily in Descriptor.AI we are already getting quite good results with our model, 87% for weighted accuracy, and there is still room for improvement. How does it apply and why it's profitable? Let's talk about sarcasm again. Imagine a call to the support service and then saying the very frustrated tone, yeah, the service was okay. If analyzed only with textual engine, there's a little chance to catch up some context and detect sarcastic move. Validating the incoming data with the tone of voice while increasing the accuracy, throwing some light onto the real issue, and getting closer to understanding what's in fact in mind of our client or customer. To achieve worthwhile results, we have been experimenting with different DNA architectures, but best results were achieved with RNNs with adding some dense layers combined with dot augmentation. Now we're experimenting with a combination of RNN and CNN to catch up more potential features with attention mechanism. Here on the slide, we have visualized the model architecture on the high level to dive a little bit deeper into the mechanics. We're extracting some features as an emphasis to build up a spectrogram that will give us a representation of the phoneme extracted. Then we use it as our input feature to train a model and experiment with the results. There are a lot of possible caveats to be aware of. For example, some emotions are really easy to mix up simply because of the volume changes. And of course, we're constantly improving our model with some data normalization tricks. Can speech recognition be advantageous not only for personal AI assistants and hotlines, but also for growing up the business metrics, such as retention, LTV, and so on? Definitely. Can this technology help to understand your customers better without the staff being involved in the analysis? Yes, it can. Will the future of AI become the future of humanity? Who knows? Does future of AI seems to be worth of exploring? Absolutely. Thank you for your attention, pun intended.